Hello and welcome to my video, Chapter 3 and 4, Lesson 8, the last one for exponents and logarithms. So we're talking about applications of logarithms in this video, and we're going to look at three different types of applications, but that doesn't mean that this is what it's limited to. It's just these are the most common ones on our exams and in real life. So our first one is going to be earthquakes. So this first question, I'm going to just say this ahead of time. You do not need to memorize any of these formulas. However, those formulas have to be used. So on a question on a test or whatever, a diploma, this type of thing will be given to you, this formula, or a formula similar to it, and it will describe the different parts of the formula. So it'll tell you that I is intensity, M is magnitude, I naught is some reference intensity. And it doesn't tell you what the reference intensity is, it just tells you that that's what it is as a whole. So let's take a look at this first question. How much more intense was the largest recorded onshore Canadian earthquake in 1946 on Vancouver Island, which had a magnitude of 7.3 when compared to an earthquake this year near Tuktoyaktuk in Northwest Territories? Magnitude of 4.2. So we're comparing these two different earthquakes. They have two different magnitudes. We're asking how much more intense was one than the other. So what we need to do is basically figure out the comparison of one intensity and the other intensity and work from there. So what we're going to do is use that formula and say 10, which is the base, it's just an invisible base, to the exponent m, which is the exponent because it equals that, equals I over I naught. So if we want to figure out the intensity, we can rearrange this and we can say I naught times 10 to the m equals I. And now what we can do, if we want to compare the two intensities, we can say intensity 1 over intensity 2. That's the ratio that we're going to be using. And so what we're going to do is we're going to say I naught 10 to the m 1 over I naught 10 to the m 2. And it turns out these two I naughts cancel. And so we have 10 to the m1, which is 7.3, over 10 to the m2, which is 4.2. Now what we do is we simplify this. And so we have, we're just subtracting, so it's 0.1, 3.1. So 10 to the 3.1. So somewhere just a little bit above 1,000, maybe 1,200 or something. Okay, let's continue on. The largest ever recorded earthquake in Chile was in 1960, was magnitude 9.5. It shook for 10 minutes. This is the largest ever in the world, recorded anyway. So when comparing to another earthquake, it was 420 times as intense. So how intense was, or how strong was the weaker earthquake? So here we have a magnitude 9.5, and we're trying to figure out the weaker earthquake's magnitude. So we're going to use that same rearranging as we did before. I guess I should use the other color, but we're going to compare the intensities. So the intensity of the stronger one versus the intensity of the weaker one was 420 times as intense. Now, given the fact that we have this m1 over m2, or 10 to the m1 over 10 to the m2, and we know that the m1 is actually 9.5, we can now solve this for the part that we want. So we can take this and rearrange it. So it's 10 to the m2 equals 10 to the 9.5 over 420. Now we can solve it for m2. How do we do that? We use logarithms. So we're going to use log of 10 to the 9.5 over 420 equals m2, because that's the exponent. So we can now plug this into our calculator and get ourselves an answer. So this is log of 10 to the 9.5 over 420, and we get 6.87. Let's go 6.86 because it rounds up. So this is the magnitude of the second earthquake. Okay, so those are a couple Richter scale examples, but like I said, there are multiple logarithmic scales in our environment. The next one we're going to look at is the decibels scale. So the decibel scale uses this formula, and again, you wouldn't have to memorize this, but it will be given to you on a question, and then you have to solve it, for example, on the diploma or on our unit test. So we're just going to compare the intensities of one sound to another, and we're talking about a fighter jet versus sound of conversation, and so we're going to compare the two. So how we're going to do this, we're going to take this formula just like before, and we're going to rearrange it. So our first step is to divide by 10 on both sides, and again it has this reference intensity, which is something to keep in mind. And then this is going to be decibels to the exponent 10, and then it's I over I naught. And so what you'll notice again, if you divide those two, so if we go I1 over I2, if we divide them, you're going to have the same sort of thing happen. So we get, oh, sorry, I forgot to do this. We're going to move that I naught over, and we get that, right? And so if we do that here, we'll get I naught 10 to the decibel over 10 over I naught 10 to the decibel over 10. And so obviously these two cancel, and so it's decibel, 10 to the decibel 1 over 10 over 10 to the decibel 2 over 10. So in this case, that would be 145 over 10, so 14.5 over 10 to the 6.0. So when we simplify this, it's 10 to the 8.5. So it's shockingly much more intense. Okay, let's look at another example here. How much more intense is the sound of a rock concert at 120 compared to the sound of background piano? Well, I recommend you pause the video now and try this for yourself. Well, you're going to see that it's the exact same question as before. So we're just going to skip ahead a little bit and say, well, we're going to have 10 to the 12.0 over 10 to the 6.5. So when you subtract the two exponents, we're left with 5.5. 10 to the 5.5. All right, one more down here that we're going to try out. The reference intensity, which is I0, is the threshold for hearing. And so what we're going to do is find the intensity of a speaker at 75 decibels in terms of I0. So you just rearrange that formula, and we already did that up here. So we just say I equals I0 10 to the 75 over 10, or we can say I0 10 to the 7.5. Okay, and then the last one we're going to look at in this video is pH. again, not to say this is the only 3 sets of things we can look at, but these are the 3 that are most common. So pH is used in chemistry all the time. You may have even seen and used this formula before. pH equals negative log H, where the pH is the value, like measurement, and then H plus in the middle is the concentration in moles per liter. So what is the concentration of hydrogen ions in pH of 10? So we're going to just go ahead and try to solve this. Probably would have been helpful to have a little bit more of an interesting number, but if the pH is 10, then we have that negative log of H. And so we just need to solve for it. First, we move the negative over. And then we rearrange it into exponential form. And this is our H plus value. So it turns out it's 10 to the negative 10. So if you pause the video now, you can try our last question out. So what is the pH of hydrogen concentrate, or what is the concentration? Sorry, what is the pH if the concentration of hydrogen ions is all that? Well, what we need to do is plug that into our formula and find our pH. So we're just going to plug it in here. So 1.995 times 10 to the negative 7. And we get an answer of, let's go ahead and plug this in our calculator. And I did this for you guys because I thought you would like the answer. 6.7 is our pH. Enjoy that while it lasts. All right. I hope this video helps you better understand all of these different applications of logarithms. But keep in mind again that you could be given whatever question that the diploma wants or I want. It might not be one of these 3. And if it isn't, what they're going to do, and if it is, they're always going to give you the formula and explain it on the question. Hope the video helped, and good luck.